Our next speaker is Dom Weldon, and he will be talking about very interesting topic, how imports work and why should I care. Dom is a full-stack cloud software engineer from London, and he will introduce himself further. It's all yours. Thank you.
Thank you very much. And yeah, I apologize in advance that I am losing my voice slightly. So hopefully it will last until 4:30, but we'll find out, I guess. So yeah, my talk today is how do imports work and why should I care? And also why should I use a tool like PDM, which is a tool that we'll come to in a minute. Just as a quick introduction to me, like we say, my name's Dom Weldon. I'm a full-stack engineer. You can kind of get a rough idea of some of the technologies that I'd like to use from the logos up there. I'm, like I say, based in central London, gives you an idea of what it might look like there, or certainly feels like this post-Brexit, at least. And actually, on that note as well, it's lovely to be here in Slovakia today. With a name like Dom, it's always interesting wherever you go. So, this was next to my Airbnb when I checked in. This was last night. My name's absolutely everywhere. And so, yeah, this is Dom Weldon back in London. And I'm House Weldon to everyone here today. So that's nice to be. So moving on, I'm also an independent contractor. I work at the moment for a very large investment management fund in the City of London. I've decided not to name them today, not for any weird, spooky reason, just because I'm here in a kind of personal capacity. This isn't a work thing. I'm just a guy that enjoys talking about Python in Slovakia of a Friday afternoon. Before that, I was primarily working in for a mathematical modeling consultancy in defense and infrastructure projects primarily. And my past was academic for a while until I sold out into tech. So, let's look at the talk today, imports. How do they work? What are these dependencies that we use in our code? And how and why might I want to use a tool like PDM? And how can dependencies make my code vulnerable? And we'll also be looking a bit at some of the harder points in the previous presentation to do with things like import lib and why that can get complicated. So the tool I mentioned as well, PDM, Python Dependency Management. So I think it was initially proposed as, but now it's just PDM is the name of it. You can check it out on GitHub here. I want to stress, though, that this isn't just oh, this tool's great, you should go for it. It's the best thing ever. And it's PDM is one part of the talk, but generally we're looking at imports as a whole. And also PDM is very standards-based. It works well with other tools. So this, I'm not connected to the project apart from working on some open source bits in here and there. This is not an advert necessarily just for PDM. So let's go back to some of the basics. This is probably one of the very first scripts you'll ever have run in Python, the classic sort of hello world. And we've got to think about what's actually going on here. First off, we've told here our command line to to associate this Python executable with this word Python. We've passed some tokens to it, and some symbols that get turned into tokens. We've got, and it's found this callable print, and it's found this string literal argument, and then it matches our arguments to this function's parameters, and it calls the function in a call object, and we see the resulting output. So quite a lot's actually gone on there that we might not necessarily think about initially. But let's make our project now a little bit more complicated. So rather than just having one file now, we've got two. And so we've turned our set of files into a package here. We are now saying that we want to use code from one module inside of another module. Essentially, Python has been told to go into another file somewhere, open it, execute the code that's in that file in the current environment, and put it into my namespace at the moment as it stands. Now, we could make it a little bit more complicated still. We could go and say, hey, this is going to be an async app because it feels a bit cooler. But we're importing this package here, async.io. But where's that come from? There's no package, there's no file there that's called async.io.py. So we must be getting this code here from somewhere that we can't see. And likewise, if we wanted to try and make our app a little bit prettier, a bit more user-friendly, we could use a library like Rich. If anyone's familiar with it, it's a brilliant CLI text-based application to make really rich, powerful text applications. But if we try and import it straight away, we get this error, module not found, and we know that classically we'll need to install this module using pip, which is the package installer for Python. We give it the name of the package, it goes and finds it, puts it in our environment for us, and now we can use Rich. But hello, we've just tried to execute our program, but there's a problem. It's saying that we've got a syntax error here. So now if we look at that, that looks like pretty much okay, valid syntax to me. I can't spot anything particularly wrong with it. But hang about, when we look at this, what version of Python we're using, it's Python 3.9, and this structural pattern matching, or the match statement, wasn't added until Python 3.10. So there's another thing that we've got to take care of before we can run our program properly, and that is to make sure that the executable we're using is at the right version as well. And so, if we fix that, we start using Python 3.11, say, we can execute our code and it runs just fine. Brilliant, okay. But something's changed in our code when we installed that rich package and the async IO package as well. I can't say anymore that I'm the only person that wrote all of the code inside of my application. We've got to think who actually wrote this code, and more importantly, are the people who wrote the code good people who want our code to succeed, or are they baddies that don't have our best interests at heart? And so in the case of Rich, this is a developer based in Edinburgh in the UK, Will McGugan. I've spoken to him a few times. He's a brilliant guy. You should definitely check out some of the Rich project and what's coming out of there. Rich, I have no problem with at all. But for example, if I was to import some other random package that says it's completely fine, what if it was written by this guy? He could be like some internet username, and turns out that actually no, we don't want this person. They might have malicious code. And so we need a way of tracking who is providing our software to us and whether it's useful and something we want to actually incorporate into our project. So there's a lot going on here, and we've got some questions that kind of come out as a result. So the first one is, where do those modules that we saw before that we can't see, like async IO, live? We also need to make sure, how do we know we're using the right version of Python? How is Python going about finding all of these extra modules and things like that? And what happens to a package when you install it? So, and also finally, how can we know that these packages are safe? So let's answer these questions and look at some of the tools that we'll find along the way. So let's tackle the first one. Where do those unseen packages live? So the example I used initially was async IO, but there's another part of the standard library that you might be familiar with, I'm sure, called inspect. So we can actually use tools inside inspect to find out where the source file for a particular callable or a particular object actually lives. And so in this case, we're just looking for find where this standard library package inspect lives, and we can see there's this lib folder. But if you know anything about Unix file systems, you'll know that that's quite a sensitive location in that particular folder there, user lib. And the important thing to caveat here is that that's actually my system Python that I'm working with here. So you don't really want to go changing anything in your system Python. It's what Ubuntu or Mac OS or whatever your operating system uses to manage certain processes inside it. So we want to have a tool that allows us to install Python easily in a particular version. And I'm sure many of you, or most of you probably will have come across a pyenv4, which is a tool that allows us to manage exactly that using a system of shims. So we can install a particular version or subversion. We can say that we want to use it locally, or we can even use several different versions of Python in the same project locally, combining it with other tools. And so if we use like a pyenv installed version of Python now, and let's look, where do these modules that we can't see live? So I know it says async IO on the one side, and we're looking at inspect, but they live in the same place pretty much. And so you can see now that there's this kind of pyenv directory, which is where our Python is living. And we can also see that we have this lib directory that stores many of the packages that exist inside of the standard library. Okay. And so where do the packages live? Well, they live in this lib directory. But let's look inside of this directory lib. So I'm using pathlib here and inspect to just sort of get a list of the files and directories that I can find inside of this lib directory. And I've edited the results here slightly. This isn't what you would see if you wrote this particular bit of code, but it's illustrative. And so you can see here that we've got files for many of the standard library packages like abstract base classes, async.io, base64, all the big names. But we've also got this site packages directory, which isn't a file, it's a directory. So what's in there? And if we take a peek in there, we can see by looking, doing the same thing inside of that directory, wow, we've got a few bits and pieces in here. This is a fresh install of Python, but we've just found a couple of our first packages that exist inside of Python that aren't in the standard library. And that one, there, pip, is something everyone will be familiar with. Pip is not actually in the standard library, but there's a module that is in the standard library called ensure pip, which will install it on your behalf should you wish. And it was created, like we know, by Ian Bicking, one of the really influential people in rationalizing a lot of the Python packaging ecosystem several years ago, or a long time ago now. So PyEnv as well, the tool that we're using here, will install pip generally by default when it installs a version of Python. And if we wanted to, we could just start installing any packages that we want into this site packages directory. But as I'm sure we know, that's not a good idea. That's not something you generally want to do. Instead, you want to isolate your packages by individual projects. Just like in the previous talk, we want to reduce the amount of complexity. We don't want, just because you're working on one project that happens to use pandas, you don't want your version of Python in another project that is doing something completely unrelated to also have pandas installed in its namespace. So the tool that we use to do this is something I'm sure many of us or most of us are familiar with. We create virtual environments that have a localized Python executable and a virtual environment contains its own site packages directory. This was also created back in the day by Ian Bicking. So this allows us to reuse the same Python executable from a tool like PyEnv that we install, but create a hierarchical way of resolving package names inside of a given environment. So, first we look in the virtual environment, then we might start looking in the standard library and so on. So just to kind of really hammer home how that works, we kind of set up a bunch of virtual environments here. We might have several different versions of Python installed. A couple of them are using Python 3.11, a couple of them are using 3.12, and there's a legacy project on 3.10. So then if we were to import a package, say this rich package that we're using at the moment, it would initially start searching through the virtual environment, and then depending on which virtual environment it's in, it finds it in its site packages. If we were to do something like look for async.io, again, that's actually in the standard library, so it would end up being, down here. You can see the animations off there slightly. It would be found down in where the standard library lives, inside of the actual kind of Python lib folder. And then if we were to look for something like pip, that would be inside of the site packages folder or directory instead, because that's not in the standard library. So that's all very well and good, but how does this actually work? Pardon me. How does this actually work in practice? What does Python do to go about finding those files? Well, before we answer that, there's an important distinction. And so let's just clarify. What's the difference here when we talk about a package and a module? Well, so the answer is that a package is actually also a module. And all modules have a name, and they're of the same type. This is this type module here we can inspect. And they are executed when they're loaded. So at import time, the code inside of your initial module file will get executed. So things like function definitions generally, but sometimes code that also has side effects. And then we can find them in this sys modules list or collection inside of the sys package. Packages, by contrast, though, they're modules. They're a special kind of module, and they're a module that has this path attribute on them. And so let's look here at the rich package we were using before, and you can see that it has a path attribute that points to a file or a directory, where we can find some more of this, the sub-packages and things like that for rich. Their init files, though, are still executed, and they're put into this sys modules. So this path attribute, and yeah, we can see where that points to there. It's important to know, though, that there are actually two types of packages. There's a regular package, which just can be thought of really as a directory of Python files. We've probably all created them. It's what you will use to organize your code. And the path attribute there is just this list of directory names. And you find sub-packages by iterating and looking through that directory. But there are also special types of packages called namespace packages that allow the dynamic loading of a package by executing code, should they wish. The path attribute there on a particular package just has to be an iterable that returns a file location. And obviously, we can create our own iterables that execute code. They might do things like look on networks. They might sniff around to find out what's on a particular machine and so on. So even by importing a package, even by the process of finding it sometimes, we're opening ourselves up to potentials for attack. And so if we take a look at how this actually works, so imagine we're importing some module from some package. Python works out this fully qualified name for the package, and then it uses this system of objects that are called finders and loaders, and they form part of what's called the import machinery of Python. So this implements a hierarchy, and the hierarchy looks something a little bit like this. So we start by looking through modules that have already been loaded. Then we start looking at the available paths that are in our sys.path at that point, and then we start iterating through the various path attributes of the modules that have already been loaded until we can find something that might match the name of the package we're trying to import. There's then a way of resolving any conflicts between how packages, if there's potentially more than one package of the same name found. This being Python as well, all of these finders and loaders are completely extensible. So we can look at what they are by default. This is just a couple of parts of that machinery actually on sys here, but the finder objects that are there in the meta path. And so you can see here this virtual environment implements its own finder. But there's nothing to stop you from writing your own or writing your own loader as well that controls how your package is loaded. Now, for 99.9% of the time and packages that you create, that's really not a good idea. If you're messing around with this, you're doing some kind of really dark arts, either for good purposes or normally very strange enterprise bad purposes that have you've been forced to go down into. Pardon me. So here we can see how the virtual environment the virtual environment system works. It adds a finder to our import machinery, and it also adds several directories to our sys path, which then allows us to implement that hierarchy of searching for packages that we saw before. So this allows us now to think what happens when we actually install a package. Well, the answer becomes quite straightforward. So if we ask what actually needs to happen for a package to become importable so that we can install it, well, we just need to have it in one of our sys path locations or available to a finder. And so generally installers like pip, all they do is use this package disutils to make sure that it bundles up the code into a format that Python accepts, and then puts it into the site packages module directory at the correct location. And so installer here, something like pip, it'll check that it can find a package called rich initially, inspects the metadata as well to see what packages rich might require and various other artifacts about the package itself. And then when it has this complete list of everything it needs to install, it'll go about downloading them and copying them using disutils into the relevant places that package should be found. Now, if you're starting to think that's all a bit crazy, complicated, I don't remember all of that, then that's absolutely fine. You don't really need to know anything about all of this to manage your packages effectively. What you need instead are good tools. And so you're probably aware of many of the kind of various different dependency management tools that exist in Python, things like Poetry and pip and pipenv, that kind of thing, and PDM as well, which I'll come to in a second. These are all very related and analogous in many ways, But I'd argue that they're, rather than just being dependency managers at this point, they're really more namespace managers. They're managing not just what dependencies we have, but also what versions of Python we're using and how we can segment lots of different parts of our project and our code. Namespaces are really important. In Python, essentially, that's pretty much all that most of our individual objects are. Virtual environments as a namespace, a Python version as a namespace, packages and modules, they're all just namespaces, as are like classes, objects, and even that strange type, the namespace inside of the standard library that you can use sometimes as well. So having tools that manage all of this is really important. And thinking about namespaces as well, it's worth remembering that if you look at the little Easter egg in Python, the Zen of Python, that it does end with namespaces are one honking great idea. Let's do more of them. And so that's why we have these managers. And so coming on to a tool like PDM, you can see the homepage for it there. It was actually, pardon me, excuse me. So PDM was actually born of a plan that was published in PEP 582 a few years ago that was ultimately rejected, which I think was a shame for the Python ecosystem generally. But it proposed replacing a lot of the kind of site packages architecture that we have with something very akin to node modules, if you've kind of come from node world at all, and creating this dunder PyPackages directory that would just store all of the different packages that you might need to use inside of a local directory called PyPackages. But unfortunately, because of the architecture of the whole Python packaging ecosystem at the moment, that was ultimately rejected. And so PDM now actually manages virtual environments by default rather than implementing these PyPackages directories. And it also integrates with tools like PyEnv and various other tools as well. It's a very standard-focused project and uses the new PEP 61 style sort of PyProject .toml for its recording, which isn't even that new anymore, but it adheres to the standard. And it generally tends to avoid adding tool-specific metadata like poetry does, say, when it could just follow the standard instead. And so we've got the pretty standard set of commands here that you might use with PDM, so things like init, and then you've got a suite to manage virtual environments. You can run code inside of your virtual environment, and there's also, importantly, this command pdm add, which replaces things like pip install. So if we come back to just when we're thinking about installing packages, let's say we're doing a quick little project to do some web scraping, potentially. I'm going to use Rich, I'm going to use Typer, the kind of layer on top of Click that uses type annotations, and I'm going to use AIO HTTP to make some HTTP requests. I probably won't want to actually install all of my packages like that because I'll also need some other ones and I'll forget which packages to install and so on. So your classic requirements.txt where you actually put in all of your requirements that you have. But as we know, each individual project itself is also going to have a whole suite of requirements that get added on top of that. And so eventually we get into a very complex situation where we can't always necessarily repeatedly rebuild our environment because package versions change and they're not properly pinned. And so, like poetry, PDM will create a lock file for you where it resolves all of the Python artifacts that you might want. So that's all of your packages to specific hashed versions, and then allows you to recreate your environment using a command like pdm sync, for example, rather than having to resolve all of your dependencies each time. Check out the documentation to find out more about how that all works. But yeah, returning to our questions, finally we've said looking at where do packages come from and what happens when we install them, and also how can you know that packages are safe? Well, thankfully, the whole ecosystem of Python packaging has really come along tremendously over the past 10 years or so. And now the Python Packaging Authority, who maintain PyPI, which is obviously the biggest registry for Python packages in the whole community. Pardon me, I always find it amazing that it actually started as like a weekend project back almost 20 years ago now, or over 20 years ago. Gosh, that makes me feel old. Yeah, now serves like hundreds of billions of downloads each year. And so but it's worth remembering that PyPI is public. Anyone at all can post, pardon me, almost there. The voice will hopefully last. Anyone at all can upload a package to PyPI. There are no particular checks on it, although that's somewhat changing at the moment. And so, pardon me, we have actually got a problem with malicious registrations. That's where essentially bad actors upload packages to PyPI with the intention of generally exfiltrating secrets or just causing mischief and so on. And if you actually look at the names of, pardon me, sorry. If you actually look at the names of many of the packages that exist in PyPI, there are lots of them with very strange names or sort of typo squatting as well. A good example was this one, Xbox Live Pi. It was discovered as part of a scan of lots of Python packages recently, and that targeted Windows machines. And you can see as well that it was targeted very much towards residential, maybe sort of young coders that are trying to do projects that might sort of appeal to them and integrate with Xboxes and the Xbox API and so on. But when it was actually downloaded and imported, it just exfiltrated secrets on the Windows machine and then posted them to a Discord server. And interestingly enough, it was actually published by that guy before Christopher 1337 or leaked. So these things are very much out there and do happen. Enterprises, so that's big organizations, spend a lot of time dealing with problems like this, and actually it can cause quite a lot of gridlock almost in the availability of packages being stopped because of CVEs and things like that. So enterprises will generally have their own Python registries that contain a mirror, say, of PyPI that then quarantines packages that it scans and deems as being suspicious. But there's lots of entire businesses really whose basis is providing these services out there. So I'll let them do their own marketing. But whilst they're a bit of a blunt hammer at times, they are very kind of useful. But for most developers who maybe are working on a project outside of work, or we're doing something a smaller company or it's open source, we need a way to guard against that particular type of attack. And thankfully, there are tools that we can use. And so one of the ones that I would just beg of everyone, if you're maintaining any Python project whatsoever, to at the very least use Safety, which is a package published by PyUp, which is a company doing the kind of similar work before. But it will check for any vulnerabilities inside of your Python packages that up until about, I think, the last 30 days, you have to start paying for things that were published, vulnerabilities that were published less than 30 days ago. But it's great, and then ultimately, you'll want to start seeing screens like this whenever you run a scan after you've installed a new package, or say in your environment, or you just run it regularly, to make sure that you don't have any packages with potential vulnerabilities that could exploit, that could open up exploits inside of your code. Finally, Python packaging and imports, they're complex. There's a whole ecosystem of tools, the import machinery that operate under the hood to import your files or import your packages when you just run that import statement. And you can actually hack into that process, and you kind of hope that if that process is being hacked, you know about it, and it's a thing that you want to happen. Namespace managers, though, tools like PDM make life a lot easier for us, and things that are definitely tools that we should use. And if you're not using an analogous tool at the moment, I would definitely encourage you to do so very shortly. Python packaging is an area that's always evolving. Security concerns are always being addressed, and if you look across to the Node ecosystem, there are similar problems at the moment that everyone sees, but there are certain strategies that are being implemented to try and mitigate against some of those. The same with Cargo and Rust, although I would argue that Cargo is doing this a lot better. And so these are evolving constantly, but it's important to make sure that you take steps independently to protect yourself from what are termed these supply chain attacks. So thank you very much.
Thank you very much. That was perfect timing. We are just on the hour. We have quite a few questions, so let's start. The first one, is PDM similar to Conda? How is it better?
Sure. Well, so yeah, hopefully this has come from someone in our sort of data sciencey world. If you're using Conda, so is PDM similar to Conda? Yes, in the sense that Conda is also a namespace manager. It installs your, goes and finds your packages for you. It installs them on your behalf to a relevant location, and also. Also allows you to kind of run inside of a Conda environment. The problem is that Conda is very much, at least in my opinion, it's a tool that's designed to almost kind of emulate how you might think about working in like a spreadsheet. Sometimes it creates a very Conda-specific environment, and the differences between Conda environments and Python or pip environments is sort of subtle, but often really quite complicated. There are definitely advantages that you get from using Conda in lots of data science projects, but it's not quite as analogous. And also Conda maintains its own registry, the Anaconda registry, doesn't it? So I would say that they're different tools. PDM isn't necessarily better than Conda and vice versa, but PDM, I think, frees you up into a much less tied-in proprietary environment and allows you to operate that kind of, definitely allows you to operate that pipeline between sort of like data science project to product a lot easier, in my opinion, than Conda. But if there's anyone from Conda in the audience that wants to come and punch me afterwards, then that's fine. But yes, so thanks.
Thank you. The next question, what do you think about relative versus absolute imports?
It really depends on the context there, I would say. So yes, often you'll want to use a relative import inside of a script that you're writing. Whereas you're making a sort of absolute import if you're writing a package, it is often one. I think it's just a bit of a too general question at the moment to really be able to offer a kind of considered opinion. But I've run into situations where both have caused me headaches in the past. So it really depends on the project and on the context, I think.
Thank you. The next one, your opinion about the UV package manager.
My opinion is that it's something I should go and look up. So, thank you.
Thank you.
Thank you.
Next question, how does PDM handle circular package dependencies?
Yes, so PDM actually has its own resolver for PDM has its own resolver here for cases where you've got packages that are, so actually I'm trying to think in this instance here, that's not necessarily going to cause you a problem inside of a package because everything's going to be the same namespace there. But yes, so essentially PDM has its own resolver. I would have to look at the specific use case of a circular package dependency in external packages there to know exactly how that would happen. But if you've got a good example, then I'd love to hear it. So yes. PDM versus Poetry. I used Poetry for a long time. I came across PDM. I prefer it. I still use Poetry on some other projects. They're similar tools, but I think I prefer PDM given that it's more standards-based than Poetry. I always really hated having the tool.poetry.dependencies thing inside of my code. That just bugged me for some reason. PyEnv and VEnv, so you can use them together. In fact, I often do. PyEnv is a way of installing and managing different Python versions on your system. So that's different Python executables. Whereas VEnv generally, you use a Python executable when creating a virtual environment. So they're perfectly complementary tools, I'd say.
Speaking of which, is PyEnv your preferred virtual environment manager?
So these days, I prefer PDM over most of those other tools because PDM has a wrapper around PyEnv and it has a wrapper around other kind of virtual environment tools. So it's a really nice little entry point for everything. I can't remember the exact question previously, but PyEnv and PDM are my kind of preferred sort of tools for that virtual environment and namespace management there.
This is a deeper technical question comparing the import async.io versus from async.io import task.
No. So in both of those cases, well, so it depends here whether or not task would be a package or an object, but and also as a class, which is also an object. Yeah, so in this particular instance, it wouldn't change anything because the fully qualified name, as my understanding of it goes, certainly in the default finders, is the same. The one thing I would say, though, is that my little stylistic flourish, at least in how I write Python code, is that I would always say import async IO rather than from async IO import task. Now, this is a really petty, trivial thing, but if you've got lots of different objects inside of your code that you're writing, or you've ever tried to build a tool to link together two libraries and you've got lots of objects with the same name, it becomes really tiresome to start saying async IO task versus sort of any IO task or something like that. So yeah, I just always import the package, unless it's an insane package that's like huge that is going to cause a load of bloat. Just import the package, because ultimately all that happens when you access that task object is it's a get attr call on the module. So you can either make that get attr call as a part of the import machinery, or you can do it as a part of the actually where you're using it in your code. A weird fact is that most of the time, actually just importing the whole package and then using async IO.task, say, is actually ever so slightly faster than the alternative. So it's not like a go-to speed hack for when you're trying to quickly improve the speed of your code. But if you do test it, it is generally, it does perform better to import the whole module and then do the get attr. So,
thank you.
thanks.
And how does PDM handle dependency conflicts? Package A depends on version X of package B, while package C depends on version Y of package B.
So it will resolve the graph. So the resolver basically says, oh, okay, I can't use these versions together, so I'm going to try and search for two compatible versions that's compatible with everything else. So just like most dependency resolvers would do. It will inform you, though, obviously, if eventually, after all the rounds of resolution, it can't find a matching version of it. Yeah, that's how it is.
Perfect. Here is a question. I saw from import a star in documentation of a small ORM project. Why do you think it was a preferred way of importing the project's functionality? Should it be avoided?
Well, yes. Gosh, from... Oh, no, so yeah, that's from the ellipsis there, the ... is like from the name of the package, import everything, not from 3up, import everything. That would be, no. Yeah, sorry. Generally, import star is like a massive red flag. Generally don't do it. I don't know what this small ORM project was, but I would just import the package and then start using the attributes. It could be that for the package to actually work, it needs all of its... if it was such that in order for the package to actually work, it needed every object inside of that namespace suddenly imported, then I would maybe it was Christopher 1337 that wrote that or something. I don't know. That would be a weird project there. And yes, I'll put up a link on Twitter or on GitHub as well after this presentation. So.
Okay, safety versus move to SaaS service. You have an alternatives?
So you mean here for things like safety check, do you just use safety as it's published in the open source world, or move to a SaaS service? It's probably a question of cost and also how vulnerable you kind of are likely to be based on what it is that you're building. For a lot of kind of just basic sort of hobby or kind of simple web projects where you're not dealing with hundreds of billions of dollars worth of other people's money, then I'd use safety check. Whereas if you are building bigger systems that have big financial or structural or defense consequences, then yeah, absolutely start locking things down with SaaS systems and that kind of thing.
Next question is about your preferred way to handle circular imports problem.
So I suppose circular imports are one of those things that in truth, I don't, certainly in my projects anymore, tend to run into very often. And I think that's more of a way of being quite strict or thinking about how you actually structure your code. So if you're getting a circular import and you're getting them often, then that might be a sign that perhaps you need to start splitting up some of your code into different modules or different packages to start thinking about what are these objects that I need and why do you need them. So, for example, I'm almost religiously these days keep all of my Pydantic schemas in any project that I work on in a separate sort of schemas package or sub-package inside of my project. So I define basically what all of my data structures are in there, and that doesn't import from anywhere else. Yeah, that's one thing. But just if you think about your structure generally, I would say rather than how to necessarily always fix a circular import. So.
Perfect. So we have two more questions. And how does PyAU prevent supply chain attacks?
Yeah, is that PyAU maybe, is that meant to be PDM or PyPI or?
I wasn't sure either.
Yeah, so, well, so yeah, so let's say how does PyPI and the Python Packaging Authority prevent supply chain attacks? Well, there are lots of people working on exactly that question, as far as I understand. I believe that there are initiatives at the moment whether exactly how well implemented, I'd need to check. I haven't looked at this in certainly a month or two, that are looking to apply security checks whenever a package is uploaded. But in the meantime, definitely the tools to use are things like safety, things like Bandit, and just static analysis tools certainly that allow you to do that, and also to follow good security practices, thinking about PLP, principal at least privilege, and making sure that you're not just running every script from God knows where your dependencies are coming from on like a really sensitive personal laptop that has all sorts of company details in or whatever. So.
And the last question you partially answered, but obvious advantage PDM has from being a VN-less manager, so effectivity-wise.
Yeah, how much more effective is it in resolving packages than, say, Poetry? That's a tough question. I haven't done any metrics on the sort of speed of resolution, say, or any of the problems that actually kind of on a huge project, the problems with resolving all of those packages. I would say certainly comparable, but if someone wanted to benchmark, then that would be a great idea, I guess. And if that's already been done, then brilliant. Yeah.
That concludes our time, our questions. Thank you very much.
Thank you.